Do you remember when I made a bicycle with an Omni wheel on the front wheel? It balanced like a Segway sideways, but you could still ride it like a normal bike because the front wheel had lots of skateboard wheels all around it, so it would kind of slide along sideways. A while later, I moved on and tried to make a bike with 2 Omni wheels. Instead of building the electronics myself though, I took the guts out of a hoverboard, including the motors. I tried to velocity match the original wheels with the new larger wheels using belt drives, which kind of worked okay, but then the only way to propel it was with EDFs blowing it along, which wasn't very successful. As soon as I'd assembled that version, I realised it would have been better to have made Mecanum wheels, which have the little wheels slanted all around them. These are typically used on the 4 corners of a robot so it can move in any direction, but I wanted to put them all in a line so the bike still balances sideways but it can screw itself along. I actually found a YouTube video from Matthew Watson where this method was used to drive a small robot. I believe this was a PhD project and it works very well indeed. I can't find any other versions of this type of locomotion, and I certainly can't find any versions that are big enough to ride on. So yeah, you can buy Mecanum wheels off the shelf, but the biggest I can find is 254mm in diameter, which is really small, and they're really expensive, like £700–800. And I already made 2 massive Omni wheels, so I guess I'm going to have to make 4 massive Mecanum wheels. Yes, of course I'm going to 3D print most of the parts. I'm building a scaled up version of my Mecanum wheels from the smaller robot I showed earlier. Each wheel is going to be around 360mm in diameter, and it'll have 12 little wheels around its circumference, so I need 48 little wheels in total. Just a quick ad from my 3D printing sponsor, thanks to Lolzbot for supporting my channel with 3D printers. I'm printing the tyres in 95A TPU from 3D Fuel, and the wheel hubs in 3D Fuel Pro PLA+. You can now get 10% off 3D Fuel products with my special code, and I'll get a small commission too. There's also 96 wedges to be made to put on each end of the axles to hold the wheels at a slant, but I'll save you the footage of printing every single one of them. I printed the TPU wheels with a 1.2mm nozzle on Lolzbot printers, and they're incredibly tough. And that means that it's very hard to push the hubs in, so it's time for the hydraulic press. Thanks to Simply Bearings for the bearings for this project, I've got 96 skate-sized bearings for each end of the 48 wheels, as well as of course some bigger bearings for the actual big wheels themselves. So we need to make some wheel hubs to mount all this on, so as usual I'm going to use some plywood CNC'd out, so we've got some holes here being drilled in a massive circle, and that's so we can attach all of those wedges around, and we also need some more holes to go and align all of the parts together with a hub in the middle and make sure those wheels are in the right place. So we've cut out some circles, and I've also got some HTD8 profile pulleys, and one of those is going to drive each wheel. So I've painted all of those black with some automotive spray paint, and you notice there's some very shiny sections on there, and that's actually masking tape which I've put over where the 4 holes are to mount each of the wedges. And that's so that I can glue those on and there's something to stick to other than paint. So I've got some solvent-based adhesive to stick each of those on, and I'm also going to screw those on as well. So basically those never ever come off because I'm going to be sitting on this. And that leaves us with a piece of round wood with 12 wedges glued and screwed to it. On the other side we've got the HTD8 pulley, and I've also made a thin plywood retainer so the belt doesn't fall off, and that's going to be used to drive the wheel. This hub fits onto a 3D printed part, which is printed with a 1.2mm nozzle, so that's a really tough 3D printed hub, and I've got bolts that go all the way through, which are a pretty tight fit. We'll just knock all of those in, and eventually that will hold the other side on as well. For now we need to get all the wheels in, so we've got these 8mm pieces of stainless steel rod which go into those wedges all the way around. To get the spacing right, I've got a couple of nylon washers, and then we can put all of the little wheels on with their bearings all the way around, followed by another 2 nylon washers on the top of every one. And that just makes it perfectly spaced so they don't move. We've got another set of 12 wedges which go all the way around there, and then you can probably guess that with those bolts sticking out, we're going to stick another plywood hub on top of that, and then we're going to glue and screw all of those wedges to it on the other side, and that makes the complete wheel. I did turn the bolts round though so that the pieces sticking out with the nuts on are in the nice recess that I left. We need to fit a bearing in each end of the wheel, but the hub was printed with a massive nozzle, so I've printed another piece with a finer nozzle, a 0.5mm nozzle. That makes it much easier to tolerance, and we can reprint that part if we need to without reprinting the whole hub, so that we can fit the bearings in nice and tightly. And those have got 20mm internal diameters. I've made 4 of those in total, and you'll notice I remembered to make opposite pairs so that the wheels go in opposing directions so they can screw against each other to travel in the same direction, otherwise balancing is going to be really hard. So all we need to do now is put them all on a chassis and put some motors on. It's chassis time! So that's my main chassis, and these 4 pieces sticking up are to hold the 4 motors. So actually the wheels go below this, and this weird saddle thing here is where we're going to put foot pegs. So we need to put the wheels on this piece of bright steel bar which is hung below that, and we need to make it all adjustable. So I've got some 20mm rose joints with the 20mm thread to match the studding and 20mm holes in to match my axle, and all of these are going to go through that chassis crossbar and be bolted on so that we can adjust the height of them and we can get that axle through perfectly all through all of them, threading the eye of the needle every time, and then we can get all of the wheels aligned and spaced correctly. So now it's time to put the wheels on, which is a bit of an ordeal. That 20mm bright steel bar's quite tightly toleranced for the bearings. I can do it, but it's going to take me quite some time to push it through and push all the wheels on. Not forgetting, of course, to put the drive belts on first, otherwise I'll never be able to get them on. There's a collar clamp on the end, and there'll be more of those along the axle to brace the axle against the rose joints throughout the length of the bike. So now all my wheels are all perfectly in line and they all run fine, and I've done up all the nuts on that studding so that we get everything at the right height so that the belts can mesh with the motor drives. So we do need some spacers. At the moment those can slide up and down, but we need to align them perfectly with the motors. You might have noticed I actually put the wheels on in the wrong order, so I had to take them all off and do it again. But even without spacers there, if I slide this up and down lengthways, we can see those wheels turning against each other, just like my little animation. So I'm very happy with how the alignment's gone so far. It's time for some motors. Do you remember the video I did with Colin Furze where I built a version of his Rhino tank and he helped me test it?
Yeah, that's what we was made for. Go through the mud!
Well, I'm using the same motors and drivers from that project. These are O-Drive 100kV brushless motors with an O-Drive S1 on the back of them. There's a magnet on the motor and an encoder on the board so the position and velocity, or torque, can be accurately controlled. This is a really neat unit, and I built a 2-stage belt reducer for the Rhino tank. This time we're going to need a bit more velocity though, so I've doubled the size of the output pulley that drives the wheels. The motor and reducer assembly fit onto the risers I made on top of the main chassis crossbar, and the belts are tensioned with blocks underneath each assembly. I made a quick stand out of steel for it so I can lean it up and work on it upright, and I've also fitted the top of the chassis on, and that's going to hold the handlebars, the saddle and the electronics, and that is a bolted on piece so that I can take it off to get to those motor assemblies if I need to. In the last Omni bike, I made a steering assembly which basically would lean sideways as well as rotating, and that's what I used to control all of the axes. However, there was nothing solid to hang on to, so that was a bit of a mistake in the end and resulted in me crashing. So this time I've just made handlebars which are completely fixed and don't turn at all. I found this saddle on Amazon which fits just right, so I'm pretty happy with the way it's looking. It's quite retro.
Right, it's going to be one of the best things I've ever made if it works, but we need to put some electronics in and get the motors powered up and see what happens. But before we carry on assembling that, it's time for a quick ad from the video's sponsor, which is Odoo. Odoo is an all-in-one management tool that provides entrepreneurs with a wide range of web-based applications to simplify the management of their business. The first Odoo application is free for life with unlimited hosting and support. They also offer a free personalised domain name for 1 year. Once you have 2 or more applications, you'll switch to a paid plan. The Odoo Website Builder application is a powerful tool for creating a website quickly, easily and efficiently, free of charge. The website configurator guides you through defining your goals, choosing the colour palette and inserting your logo, adding pages and features and choosing your theme. Once the structure is in place, you can start customising. Simply drag and drop blocks to customise your website. You can customise each block, adding content including images, text, video, documents and functionalities like animations on blocks and images, changing typography, colours and image shapes. The grid lets you easily lay out and organise your content blocks. AI-generated text is available in Odoo to populate any sections. I quickly put together a website about this project, and you can try out Odoo now by visiting the link in the video description. Right, let's get on with the Screw Bike Mecanum Wheel Omnidirectional Collinear Drive Bike project.
So I've made an electronics enclosure, and in there we've got a Teensy 4.1, we've got a SparkFun BNO 086 IMU, and we've got the CAN bus transceiver to control all the O drives. On top I've got a battery monitor, an LED strip which is actually at the moment visualising the IMU data. I've also got various knobs on there, so we've got a trim control, which is for the inertial measurement unit data, and I've also got a switch to initialise the O drives, and I've got a volume control we'll talk about later. I've got connectors coming out including the CAN bus, USB power, the 48 volt power so we can monitor the battery, and some connector to go to the handlebars for all of the switches. I've made a battery box which holds 4 6S LiPos, and we're going to put those in series and then pairs in parallel, so we basically get nearly 50 volts out of that. There's a 200 amp contactor on the top of there, and that's going to be linked to the e-stop on the handlebars so that I can actually cut the power off if I need to. The electronics sit right in front of the saddle there, so they're nice and accessible to control. Yes, that's a USB boost pack powering them, nice and professional. The grey cable is CAN bus that's daisy chained between all of the O drives to control them, and all those batteries sit at the back. And yes, I do have a cover there to cover the dodgy bolts, which has got 50 volts on. I've built quite a few balancing robots in the past. There's a playlist in my channel just for balancing projects that use various means to make unstable things stable. The main thing that makes balancing robots work is a PID controller. This takes the angle data from the inertial measurement unit and controls the wheel velocities appropriately. The proportional term simply means that the wheels go faster if the angle is greater, but this isn't sufficient to make the device balance properly. The most important part is the integrator. The output of the integrator is the area under the graph, so if the angle is constant as time goes on, then the output increases as this area increases over time. If the angle is increasing, then the output gets bigger exponentially, so the integrator makes the wheel velocity accelerate to catch the robot as it falls over, which happens constantly. The derivative term is the tangent of the curve of the angle data, so this makes a short sharp velocity movement to damp any overshoot. All 3 terms need to be tuned for the mass and power of the robot, which is a bit like focusing in a camera with 3 lenses. But typically the highest value is the integral term and the smallest is the derivative. However, if the device is left at an angle without the motors powered on, then the integral term tends to accumulate a large value, and when it's finally time to balance, then it makes the robot suddenly kick until it's stable. This was an issue with the first Omni bike, so this time I've got a control so I can slowly turn up the output, which makes it less likely to break my ankles when I power it up. The button initialises the O drives, and now I can slowly ramp up the output of the PID controller to make things balance without it kicking so much. It was pretty easy to tune up, but bigger, heavier robots tend to thrash around less because they've got more inertia, so it's much easier to tune the PID controller to make them balance. Right, let's put the saddle on. I have in fact tuned this up to have a person on rather than no person, so this should be working pretty well. And I'm pretty happy of how well it's working. It's almost as good as a Segway.
Oh yeah, this is really good. This is so much better than the last one made of a hacked hoverboard, mainly because I couldn't retune those PID parameters on the hoverboard. So even just a slight bit of mass shift causes this thing to travel, which is good. It's almost as good as a Segway. I've definitely got enough velocity for balancing there, but what we need to do now is try and screw it along by moving those wheels in opposite directions. And if that works, then this is going to be pretty cool.
So I've got a twist grip on the right hand side which moves in one direction, and I've also got a toggle switch so that I can drive in forward or reverse. And all that's going to do is make the wheels turn in opposite directions to screw itself along and transpose that value over the balancing value.
Right, let's try and go forwards. Whoa. Oh, it works. Oh yeah, this is brilliant. This is brilliant. Oh yes. Way. I think we might be slipping slightly on the smooth floor, but this feels amazing.
Rotating is controlled by another twist grip. Ideally I want a twist grip that rotates forwards and backwards so I can turn left and right, but I couldn't find one that does that, so I've just got another direction switch, and we'll see how that goes. I did think about having foot switches for steering, but I thought probably this is going to fall over at some point and they'll get buckled or broken if they're attached to the foot pegs, so I decided handlebar controls were best. Now, of course, the wheels are different distances from the centre, and that means that they need to rotate at different velocities so that we can rotate around the centre point. Basically, one circumference is bigger than the other, so the outside wheels need to go faster, and we need to take that into account.
Right, let's see where rotating gets us. Oh. I think I want my mass in the middle since that's where the rotation point is. But yeah, that seems to be pretty cool. Whoa. Whoa. That feels amazing. Right, we need a bigger space to test it than this though, because there isn't really space in my kitchen. This is amazing! It's one of the best things I've ever built!
And yes, the headlamp does work for those of you who celebrate. This whole project is going to be open source, as all of my projects are, so all the CAD and code is going to be published on GitHub if you want to build your own or use any aspects of it for your own projects. If you'd like to support me through a YouTube channel membership or Patreon, then patrons and YouTube channel members get access to all the videos up to a week early and sneak peeks and pictures of what's coming up, plus Discord benefits.
And speaking of open source, I'm going to be at Open Source 2024, which is June the 15th to the 16th in San Francisco. But it's a different type of source apparently, or something. Anyway, there's going to be 150 YouTube content creators and 500 community exhibits, but they're looking for more exhibits, and you can apply now on the open source website at opensource.com. And if you're successful and they accept your exhibit, then you get in for free and you get access to the exclusive Friday night kickoff party, which I'll be at along with all the other YouTubers hopefully. So check that out now.